Okay, so this is where we get to some technical overview. The first part, introduction, was all non-technical. I didn't tell you anything about what we're going to learn, but we've learned a lot through this interaction. And I'm really happy with some of the answers you've given, because it's consistent with what I planned. And hopefully I can execute that also. So, I said programming then and now. And then means old and history, right? And there's a guy called Knut. How many of you have heard his name? So he said, I think he's the one who said that program is algorithms plus data structures. So that's the reason why we have languages. Why don't we program in 455 languages? Well, Turing machines are good for proving some theoretical limits, but they are not what you want to use to program a compiler. Okay? Though theoretically, they are more powerful than Java and C. Why are they more powerful than Java and C or any language that implements on a computer?
Turing machine is the most advanced computer that can exist. Even having even having a multi-threaded Turing machine will get the same amount of time.
So it's the most powerful one, but why is Java not as powerful?
Infinite resources, infinite memory, infinite processing.
So a Turing machine has how big a, yeah.
I was going to say recursively enumerable languages.
So why is Java not a recursively enumerable language? And the reason is that Java has got a limited tape. It's got limited memory. Okay, even if you think of a hard drive, ultimately it's limited. Whereas all of these Turing machine, which defines the gold standard for recursive enumerable, has got infinite tape. So basically Java and C are all just finite state automata. They all have finite state. So even a push-down automata has got an infinite stack. Okay, so that's the theoretical issue. Yeah.
Does that mean that Java and C can only be recursive languages?
Java and C are finite state automata. They are finite in theory. In theory, in practice, they are Turing machines, right? Because the data we process is finite. So that's okay, as long as we have backups. So, so they're not even push-down automata, because push-down automata has got an infinite stack. Okay. So the reason is programmer efficiency. A lot of you guys were talking efficiency, and the reason is to really make it efficient for programming. Okay? And different languages make different trade-offs between how flexible they are, and how the amount of restrictions they impose, and what kind of programmer productivity they have. Okay, that's it then. And today, you guys want a job from this course, and you expect to do coding. But lots of people who want jobs take what kind of course that is almost the opposite of programming? Web development, that's still programming. It's toy programming. But what's the craze right now? Algorithms? So that's still because you think. What's the craze that requires you to not think also, and things just come automatically?
Machine learning.
Machine learning. Okay? I mean, when I studied computer vision, we studied all these algorithms of computer vision. And what do they do now? They get some data, throw some statistics at it, and out comes the answer. Okay? And that's the craze right now. You want a job, you want a really high-paying job, drop this course, take an ML course. But you won't get into an ML course. So you might as well stay in this course. Right? I'm going to we're going to talk a little bit of machine learning too. Okay? So that he can get a job also with the machine learning thing. Okay? And I'm going to show a connection. So a lot of you guys said, I want to see the connections. This course is going to be all about connections. Okay, so I want to show you there's a natural progression. As we go from language to language, we're actually going more and more towards machine learning, towards doing less and getting more for doing less. Okay? Till ultimately we end up with machine learning. And we are losing some too. Okay? Losing control. Losing maybe the correct answer you might get, the correctness of the answer. So that's going to be sort of the roadmap, that we're going to just go from C, which imposes no restrictions, and gradually go towards machine And machine learning is actually, that's a new term invented by statisticians, but the programming people have been calling it programming by example. Just give the example and out comes the program. Okay? So I'm going to actually look at traditional programming by example, invented by the programming language people, and also contrast it with machine learning. But that's a very small part. So please, this is not a course about machine learning. I'm just saying we have a path towards that. And yeah.
I'm sorry, I can't hear you very well.
You can't hear very well? Yeah, because of people. Come forward. But we have only a few minutes left. So, but that's the goal. So, what languages are we going to use? And if you really want to draw the connection between languages, one way to do so, can somebody in the back just shut the door? So, I'll just wait for him so that he can also. Thank you. So the big doors are shut too. Okay, thank you. So, one way to draw comparison between languages is to take the same example and do it in different languages. And what's the most popular example people use when they do overview of a language? Hello world. Okay. So here's hello world. In Prolog, which is the language we will use. Okay. In ML, there's another language we'll use. SML just means standard ML. Lisp, okay, I've already hinted. Bash, that's also a language. C, something you should be familiar to some degree with. And Java, something that you should be familiar to a great degree. Okay? So here's Hello World in how many? Six languages. These are the languages you will program in. Okay? There will also be languages to which I refer when I cover the more theoretical aspects, which you won't program, you won't program in them, but you will learn them all. Okay? So, what do you get from this slide? You get, what do you learn from this slide? So Java looks pretty bad here, right? In fact, when people want to criticize Java, they say, oh my God, how bad is Hello World in Java? And Bash looks really good, right? So does that say something about the language, something about the example? Something about the example? A language for tweeting might not be the right language for writing a play or writing, a work of some deep literature. So this is where, depending on the task, something may be better than the other. Okay? And C is less verbose than Java, but more verbose than Bash. Okay? So you must be getting something through the verbosity, which is not being apparent in the Hello World. And what about the real one-liners? Do the one-liners tell you anything interesting about the languages? Yeah.
Let's just use some, because I will ask what application should be used, but it seems we could use some weird symbolic notation.
So this is kind of weird.
Yeah.
And the other ones are
weird.
not as weird.
Yeah.
But the other ones, yeah.
Well, it looks okay.
Yeah, so there's really, it doesn't look like there's like a keyword for like a print call, so just kind of knows to do that. And you're talking about SML, right?
Yeah. So there's no keyword there.
Yeah.
So these are all syntactic things, right?
Right.
They don't seem very profound. The semicolon, this funny T there in this, but you're not getting anything from this example. So Hello World is one of my least favorite examples. I work in distributed collaborative systems. And for us, when a distributed collaborative system says Hello World, it says Hello World to multiple people. So Hello World makes sense. When you go and write a program, it says hello back to you. You never understand why I say Hello World. So I've never understood that point of view. More important, Hello World has a stupid thing to do. Print. And to go and show how a language does a stupid thing is senseless. So we will not go and use hello world as an example. And what will we use as an example? We've got 3 minutes. So it brings out many syntactic differences. And you see how every one has got their own syntax. Somebody ends with a dot, somebody ends with a semicolon, somebody says format, somebody says print, somebody says echo. People can't agree, right? And that's kind of funny. But you know, almost every variation is possible here. But we only see syntactic differences and make the more popular and practical languages look bad. Okay? So this is not going to be our example, but I do want a common example. And the example is going to be a grading program that goes and tells you whether you passed or failed. Okay? And we have 2 minutes left, or 3 minutes left. Can you guys figure out from this data? There's many ways to figure a formula that explains these data. There may be multiple formulae that describe this data. So what you see here is on the left column, you see this is actually a file that I've given to the backup program for decision, a machine learning program. So we'll see what that machine learning program does with it. And then you see how well you guys do compared to a machine learning program from the data. So we see on the left the total score, on the middle the final score, on the right whether they passed or not. So the grade is a function of final score and total score. And can you guys figure out what that function might be? Oh, there's more than one function possible. It's too much data. Yeah. You have to get at least a 40 to pass. You have to get at least a 40 to pass. Good. That's one constraint. Is 41 enough? No, do you see 5930 is false.
I like to look at it as being weighted, where I see 60, 0 true, so if you get 60 on your assignments and 0 on your final, you still pass.
So you still pass if you get 60.
So if you get 0 and 40, I think that should also be true.
So you're saying that the data are bad, but at least you get 60 is enough, right, to pass. But sometimes 40 is enough to pass. 40 is enough to pass when there's 2 variables here, the final and the total. When? So 4079 is fail, or 4080 passes. So you should get at least, so that's the constraint. So you can see why machine learning programs will have trouble, right? So 60, total greater than equal to 60 implies pass, and final greater than equal to 40 and total greater than equal to 80 pass. Okay? So that's going to be the problem we look at, and we'll see how to do this problem now in C, list, Prolog, SML, and we'll also see how to do it. We'll see how to do it concurrently. Also, we'll do concurrency also. We'll do distribution also, and we'll do this problem in many, many different ways. And that will be the overview. And then we'll go in depth into each language and study it. Okay, let's start. So the good news is we have a clock now. I put in a request after 3 o'clock yesterday, and by 5 o'clock they had it. So your tuition dollars are being well used. Bad news, we've lost a TA. So I've spent most of my energy since class trying to figure out what to do. And, you know, computer science is so popular and so lucrative in some sense that there's really no graduate student available for TA-ship. So one of the faculty members is going to make his RA perhaps become a TA, and then maybe we can play some musical chairs and get a TA. So we lost a TA because he needs to graduate this December, and you know, doing 2 courses half-time each is, I don't blame him. Okay. We'll figure something out. So I just haven't had time to process many things as a result, like process all the Piazza messages. I know a lot of diaries have come in. but there was also an issue about my links, and I haven't uploaded my PowerPoint either, so we'll get to it. Okay, hopefully things will get settled today. Hopefully. So we're going to carry on from where we left, but here's a thought I had today, especially because we're short-handed. I'm happy that many of you have submitted your diaries. At least have created diary entries and posts, and which you can edit later. And along those lines, so we have credit for answering questions. We have credit for noting down questions and answers. How about credit for creating quizzes based on that? Quiz questions, multiple quiz questions. One person likes it, so I'm happy to. As long as one person likes it, I'll put it in. So, for instance, let's take, you don't like it? Or you're smiling? You love the idea? Oh, good. This is...
So wait, I write my own quiz and then I take it?
You write your own quiz and you get points from me. Okay? We'll create a Google Doc, which you can all edit. Okay? So the early bird gets the points. If you can't repeat a question that's already in the Google Docs. Okay? So for instance, I don't know what we learned from here, but we certainly didn't, the syntax was not one of those things. So please don't go and ask a question saying, oh, every statement, every program fragment in Prolog must end with a dot. Okay? Yeah, it may or may not, who knows, I can't remember that. But it does. And, you can ask a question such as, you can ask this question for every one of these languages. Must a program fragment be embedded? A program fragment must be embedded in a function, a class, a package. Okay? And the answer is no for most languages. For most languages. For C, it must be embedded in a function. For Java, it must be embedded in a class. It can be embedded in a package, but it needn't. Okay, so it's a question that is somewhat conceptual. Okay, and that's a very simple thing. I'm not going to ask you that question, or I might even ask, but it's a conceptual question. But so that's something that's even more learning for you. So I think if you come up with your quiz question, you will learn. Getting points. Yeah, you'll get points for doing that. And then in Piazza, you can discuss the questions and answers. If I get the time, I can even make a quiz out of that. But the point is that because you submitted the question, you get some points. Okay? And this is great. I mean, I really consider a class to be not a one-way transfer of information. Typically, I get more than you guys get from me because there's so many of you. And when I ask a question, I always get answers that I've never thought of. Okay? And I try to go and put back that stuff in the slides. So it's in that spirit. Okay? Fine. Anybody dislike the idea? I'm just curious. Okay, it puts more pressure on you in some sense, okay, but again, I think it reduces the chance of being hostage to just an exam result. Okay, so we looked at, there were a lot of you who wanted to know what languages we'll be considering. So these are the languages that we'll consider in depth. Okay, we will consider we'll consider a whole variety of languages with which I'm familiar to illustrate points conceptually, but I won't expect you to know the languages, whereas these languages I'll expect you to know because you would have programmed in them, or at least you would have looked at them in depth. And the question at this point is not so much what these languages are, because, like I said, there are a lot of resources available to study these languages, but why are we looking at these languages? Why did I choose? And there's many languages I could have chosen to make the points I want to, but I'll try to go and motivate each of these languages. Okay? And C and Java you looked at already, so that's going to be somewhat easy. And there's very little programming in C. So Hello World, we decided, was not the best example to show the strengths of some languages. The example I've come up with is also not that great. Okay, it's something that I can use to quickly illustrate some points. It does not show all languages it does not show the strengths of each language, but it does allow me to go and show you a continuum. Okay, and the continuum is the one I want to emphasize. Okay, so I gave you guys these data, and I said, hey, can you figure out a set of rules that are consistent with these data? Okay, and it took you guys a bit of time, and you didn't quite get it, and we'll see whether a machine learning algorithm can get it as better than you, or as well. But the general constraint was that you pass based on your total. That's what normally you pass on. Okay, but I'm one of these people who goes and looks at other factors too, and this is when I said I use a fudge factor. So one of the things I might look at is your final. Did you do better at the end than you did during the semester? That's a valid criteria. And typically I just look at individual cases and say, yeah, I'll bump them up, I'll bump them up. It'll be nice to have a rule for that, or to learn that stuff. And the rule that comes out from these data is that for this particular class, I decided that, look, even if you get 40 on the midterm, you'll pass as long as you got 20 points above the average in the final, okay, the average total. Okay, you may or may not like this rule. I don't know if I like this rule. It's just something I put in here. Okay, so I don't think I'm going to make a lever for 20%. By the way, maybe 3%. I might jump you up. So don't take this literally for your class. Okay. In any case, I said the fudge factor is only maximum 5%. Okay. So this is the problem, and when you're in the real world, you're given a problem by some customer who can't solve the problem, and you're supposed to solve the problem. So maybe they just gave you these data and said, figure out the program. I don't want to deal with C or Bash or whatever you're going to use. Okay. So let's go and try to write this in C. Okay. And now, the customer just wanted the result, but we have to come up with the user interface also. They didn't tell us the user interface. So we'll implement something that we can implement relatively easily in C. And just please input the total score, please input the final score, and it tells you whether you pass or not based on that. And it keeps doing that in a loop, and the loop will end if you enter a total score of negative. Okay? That's the goal. Now, you've all done C in 411. Some of you have done C in operating systems. You guys really know C. You know C more than I do at this point. I used to know C. But how many of you feel comfortable that you can write this program in C? How many of you? Okay. So not all hands have gone up. Okay. I never feel comfortable I can write something in C. Just because I haven't done it for a while. So I Googled for everything. How do you do an assignment statement? No, I didn't quite do that. But almost everything I Googled for. And I found there are things being invented in C that I didn't know since even I last programmed. Okay. So I was pleased to use those. So I'm glad I Googled. Otherwise, I would have used old C. Okay. So this is a C I've come up with. It seems to work. Those examples worked. And, you guys want to know the relationship between languages, which again, I was very pleased to hear. So Java syntax is inspired by C syntax. Okay. When C was popular, so was a language called Pascal, which is one of my favorite languages. And Java decided to go with C syntax rather than Pascal. Okay. It went with Pascal spirit, but C syntax. In fact, it went with the spirit of a language called Mesa, that I'll talk about at some point. But if you're a Java programmer, what might you be surprised with in this code? You can't do that in Java? I think in Java you can do the same thing. Yeah. You can say while true, but you can say that too. Am I wrong? Yeah, you can do that. Yeah. Yeah.
It's not in a class.
It's not in a class. Okay, that's interesting. That follows what I talked about earlier. Yeah.
I was going to say the int return type.
The main returns an int, whereas in Java it's a void. Okay, so that's a difference. Okay, Robert.
Pointers.
So can you just point out something that is a pointer? I mean, what? So we've got this ampersand sign here, right? For before total score and before final score. Okay, and Robert called that a pointer. So what? Robert knows the answer. So anybody else know what is? Why am I doing this ampersand sign? Yeah. So that's interesting. scanf is going to, scanf is a void method or a method that returns a value? It's probably a void method, right? No, it returns whether it's negative, some error. Okay, so there are no exceptions in C. So that's why main returns an int, by the way. Okay, main returns an int because we want to know whether it failed or succeeded. And you do a negative number if it failed. And by the way, you C programmers, please correct me. I mean, this is all from memory, and I was about your age when I did it last, okay, which is a long time ago. So scanf has, there are no exceptions in C. So Java has exceptions, so we don't need these special return values, okay? And so we can only return one value. It can either be a struct or it can be a primitive value. They didn't want to define a struct for it. Struct is a record, it's like an object. So they decided that they're going to have variables that get changed. You pass something to a method and it can change the variable. Okay? Java doesn't do that. In Java, you go and just take whenever you call a method, you take the value, you copy it into the parameter, and that's the value you have. Whereas here you can change that. That means you need to know where to go to change that. So you get the address, and that's what you're calling a pointer. Okay, pointers, yeah.
I'm sorry, could you explain that one more time?
So 411 guys didn't do that well for you. So you haven't seen this before?
No, I haven't.
Okay, so if you want to, yeah, that's fine. You know, I mean, you can easily forget unintuitive things. Okay, so what we're going to do with scanf is a read method. Okay, in Java, when you call readline, it returns a value, right? So you don't need your parameter to be changed. Scanf is going to return a value in case there was an error. Okay, in case you reach the end of input, for instance. Okay, so we need to somehow get the value back. So we will give it a variable and say, please store your result in that variable. In Java, you give it a variable, a parameter, and you say, hey, method, consume the value. There's no production of value. If you want to change that variable, you need to know where in memory to go to. So you need to pass it the address. If I did not do an ampersand, it will take the value and copy it into the parameter of scanf. When I did the ampersand, it went and copied the address of the variable into the parameter, and then you can go and dereference that address to go and get the actual value. Okay? And if that's still not clear, Google, and you'll get detailed answers. But that's the real point. Yeah, you had a follow-up question?
Yeah, I was just going to say, so in Java, you would just declare a variable and then set that equal to whatever you have as readline instead of.
In Java, you can't do this. In Java, you have to return an object back, return the value back. You can't go and get a value back from the parameter. We will study this in great depth when we look at in-out, in parameters, in-out parameters, var parameters, and addresses. Okay, so if you don't quite get it, that's okay. But that's the basic point. But main point is that there's something different here. We are passing addresses, and passing addresses is kind of tricky, and I'll get to that again later. Okay. So other issues. Okay. Anything else that's kind of confusing here? Two people who have already answered, so I'm happy to choose one of them, but anybody else? Yeah.
So what is this, like, underscore IONBF?
Haha.
Why is there, like, underscore?
Set v buff. So here I write my first C program after years and I can't get it working. And I go, and you know, I am at a loss completely. Anybody know what that is? Is your hand, yeah.
I think it's like, so you can pass in data and the program won't put out data until like the input results here. Is that really true? It's like buffering for the output.
It's buffering for the output. So what was your answer going to be?
Mine was going to be something like buffer the amount of memory it's holding for it.
So you know, there's the word buffer there. And you guys are on the right track. At least they had named the method well. So when I didn't put it, and I ran the program, I never got a prompt. Okay, and you see that I'm printing a prompt. And I said, God, I can't even do a hello world. You know, I changed the program to hello world, it won't print hello world. So I Googled and I kind of figured out what's going on in the operating system. So I went and Googled and say, how do you flush the print buffer in C? Okay, because what happens is that it's saying, you know, and I think in Unix this might work, and I'd been using Unix in my past life, and here I was doing it in Windows. So it just is saying that please flush the buffer. Don't just defer printing it out, because by default, at least on Windows, the program just buffers it and says, at some point I will go and show it to the user. I don't have to show it right now. And that's because the C treats, and a lot of languages treat the file and the console very similarly. And you don't want to go and write everything to a file as the data are produced. You want to wait and buffer that stuff and then write maybe a whole block. Okay? So by default, it doesn't flush, and at least on Windows. Okay? So I had to go and say, hey, do flush the buffer. Okay? Am I right for those who know better? Okay, maybe you don't know better, but that's what I had to do. Okay? Anything else that's surprising? Yeah.
Are there conversion characters in Java?
What conversion are you talking about?
The percent.
Yeah, so this formatted string, originally Java didn't have it, now it does. Okay, I'll show you a Java program that actually has that now. Okay, when we go to Java. So yeah, I think this is what I have. Flushes output, so prompt can be seen before input. Okay, and this ampersand is pass address of input variable to scanf so its contents can be changed. Okay, and that's a very powerful facility that you can pass a formal parameter, an actual parameter that whose value gets changed after it's called, and makes the life of compiler optimizers hell. Okay, but then, you know, when you're programming in C, you're saying, look, I know better than any program does, so I'd rather go in. I'm doing all the efficiency myself. I don't need an optimizer. Okay, but this is how you get something called aliasing, where you have two different variables that are pointing to the same value, and that makes optimizers' life hell. Okay. Some of you wanted to know the nitty-gritty of implementation details. A lot of what you see designed in languages is influenced by how the languages are implemented. And so this is the reason that Java decided to not have addresses. Many reasons. Okay. Okay. Now, why are we, you know, we saw in languages that we don't have to embed this kind of code in a function. But C is requiring that. Now, you know, Kernighan and Ritchie invented C. Who knows what was going on in their head? So we can just interpret what they did, just like we in English interpret what Shakespeare did, and we don't really know what Shakespeare had in mind. So we can try to figure out. And why do you think you must, or any code you execute must be called directly or indirectly through main? And we have to conjecture here. Yeah.
I think it just tells the machine exactly where to look for the extra video, that it's not just looking anywhere or it's looking like everything in the file.
So it makes it a little easier to find out. You know, you name the spot to look at. And if we have name and address kind of bindings, then that's easier if that's what we're keeping, right? Good. Anything else? I mean, if you are going to use C and you want to, you see a hello world program with int main there, is that going to help you later? I know we know that we have to type some extra, but is that going to help you a little bit as you further develop your program and make it bigger? Yeah.
I mostly feel as if the main method was sort of added not for the computer, but for human beings themselves to understand where the main processes were occurring.
Excellent point. You know, in general, whatever stuff you put in to make the human being's life easier also makes the compiler's life easier and the system's life easier. Okay? So yes, indeed. That makes the human being's life easier too, because they can figure out, hey, here's the code, and oh, where do I start from? Search for main. There's the main. That's where I start from. So that might be good too. Yeah.
Yeah, on top of that, I was thinking of it more from a reverse engineering perspective. For example, we are looking in some C file for always knowing it starts at main, you don't know the difference between main and start. If start could be for some arbitrary function, you're doing it also with stop. Because you know that the code really is in main.
So you know how to distinguish main from start, which is kind of consistent with what he said. Yeah, and of course, you know, the way other languages work is that anything that's not named is the first line of an unnamed block of code is the start, okay? So you have to go and find that first unnamed piece of line, whereas here you can just look for main, okay? But that's interesting. We're assuming we're going to have a start and a main, right? By seeing the hello world example in main, do you know how to write the start function? You just saw the syntax, how to write a function, okay? So you are encouraged. The hello world program tells you that this language has functions. It also gives you the syntax for functions. So it's kind of prodding you towards writing functional programs. Now in Bash, you don't have to put the starting code in a function, okay? And then, you know, I didn't know how to go and define a function in Bash. I had to search a lot, okay? Whereas in C, I had forgotten that it returned an int and it didn't do a void. But having seen that, I said, oh, I know how to make my start function because I have the syntax there. So it's kind of prodding you towards more functional decomposition. Whereas Bash is saying, look, functions are the exception rather than the rule, okay? You just want to write a few lines of code. Why do you want to type extra? If you really want to write an essay in Bash, okay, this is how you go and do functions, okay? So people were saying which language is good for what. We are seeing that compared to Bash, C is good for larger programs, okay? It's something that will have functional decomposition. Yeah, Robert, you?
I mean, it reinforces pipelining and Unix philosophy to force that exit code so you can just string things together.
You can string things together and string things together, and that has to do more with piping and file descriptors other than what you call the functions. That has to do with IO descriptors. But I think it's more along the lines that, look, you know, we know where main is. We can search for main. Not only that, the programming environment can show you main. It can find the main and tell you here's where the main is. So it's, and again, we're trying to figure out what Shakespeare meant, okay? So, and a lot of these designers didn't think about what they were doing. They just did it intuitively, okay? And we're just trying to formalize things as academics tend to do sometimes, okay? Other things? Okay, so here we are talking about the possibility of writing other functions. Did I do a good job here using C? Put on your 401 hat. 401 tells you, 110 is supposed to tell you how to program. 401 tells you how to program well. Have I programmed well? And the answer is no. So, firstly, you didn't learn how to call a function. Well, I called scanf. Okay, so you know how to call a function there. So, from a pedagogical point of view, I might have some problems. But repeated code, what is repeated? Premature end of file. And anything else? Any other? So, there's repeated code. That's one problem. Yeah. If scanf is repeated. I could go and parameterize that and make it a function. Excellent. And if I get rid of, if I made it a function, then I won't have that repeated. Anything else?
One thing I would like to see would be a comment for the set buff line, and it's kind of esoteric.
So set vbuff does not have a comment. I don't like comments. I'll tell you a better answer to comments later. What is a better substitute for comment? So you want to comment, yeah. Sorry? Descriptive naming of what? I mean, I have to call set vbuff, so I have to live with set vbuff. That's what the name they gave. But what can I do to make it more explicit? Create a method that has a good name. Put set vbuff in it. Right? And now we don't have to rely on comments, because what happens with comments is that your code changes, your comment doesn't change, and that confuses anybody who's reading it. Okay? So comment when you need to, but many times, most of the comments that I see in code could have been replaced with writing better code. Okay. Anything else? You guys know the problem well. Yeah.
I don't know if there's a problem with casting, but you have pass and then you can change to a string.
So you're saying I'm changing that into I'm changing the total score. No, what am I changing into a string?
The pass equals the boolean. You can just print is pass.
Oh, if I print is, so C doesn't have booleans. The C I learned. Okay? And I just Googled and said, maybe they have invented booleans. And I had to look through about 10 Stack Overflow things. And I finally found a way to do booleans because I like true and false. I don't like 0 and 1. Okay? So notice that I imported stdbool.h. That's not by default. It's kind of booleans, but if you go and print a boolean, it prints you 0 or 1. So I had to go and convert that into strings. So I mean, I didn't write it like a C programmer, okay? I wrote it like a Pascal programmer. C programmers will use short names, underscores, they just say that we are real programmers and we don't need to worry about people understanding code because the people are very smart, okay? And so I had to do that, as it turns out. But there's one thing, those of you who've taken 401 with me, and I know at least 2 or 3 have, you lose some points for, I'm going to look at Gavin, right? You lost a lot of points for not following a certain style rule, especially when you guys did the animations. What's the style rule you, yeah? Indentation? Oh God, I am awful with indentation. Control-Shift-F in Eclipse. Let it do the stupid indentation. I don't want to think about indentation. So I know a lot of people go and take off points for indentation and formatting. And you look at all the style rules, some of you who've done 401 with me, they tend to enforce indentation. And I say, why? Let the tool figure out what it wants to do. So, but yeah, and I had to fight PowerPoint and make sure that so there's a lot of stuff going on there. But my indentation is awful. I just write everything unindented and just say Control-Shift-F in Eclipse and it will format for me. But something else, something you lost, yeah. Oh, because how do I quit otherwise? And do you really want to trust the user? Never trust the user, okay? I've asked industrial people, what makes your life hard? Where do all the errors come? And they said, checking user input for errors and doing concurrency. Okay, there was a third thing I forget right now. Okay, but do you really understand the program? I mean, do I need some comment somewhere? Yeah. Not in C, not in Java. Okay, not in any language I know actually. Okay. But in the functional languages we do. Okay, so that's a good point. We'll see why we need that. So students in my 401 class hated me for enforcing this rule. Magic numbers? What's a magic number? Yes. So you just put a number there and we don't know, yeah, and the person next to you, why do we not want magic numbers? What's the answer to magic number? Yeah.
We don't want magic numbers because someone who's reading the code may not understand what it means or why it's there. Or like
So I mean, we guys went through an example. We know 60 is the threshold. We know 80 is the threshold. But it'll be nice to give it a name, right? Again, people give comments there. Just give it a name. Yeah.
So the issue is the scanf you're checking if it's not equal to 1, but I think that normally when there's an error, it's supposed to return -1. They check for the wrong thing.
I took this stuff from somewhere. So is it? So.
Is that another issue with this thing?
Hmm?
So, is that another issue then? So,
Who knows? It works. It works. I got it from Googling somewhere. I said, how do you read input in C? Okay? And I saw some code and I plugged it in and it worked. But, and I used to know this really well, trust me. Okay? I've taught advanced operating systems where it's all done in C. But, I stopped teaching it because I got tired of debugging C programs. Yeah.
So you just have a random arbitrary 60, 80, 40. What if later you wrote this program and you want to change it? You didn't change the grading rules, so you want to call them their own thing. For example, total passing 1 would equal 60.
Right. So you're saying if I have names for these things, then I can change the names easy, especially if they're repeated. As it turns out, none of these values are repeated. But so it's good for readability to have some declarations and also repeated. Okay, so you're all with me, right? But trust me, my students 401 hated me for that because they had to do a lot of manipulation of numbers, and they didn't want to go and say starting X, starting Y, width, height, I mean everything, because there was a lot of magic numbers. Okay, but it's amazing how many people. By the way, how many of you have heard the term magic numbers in your previous classes? Okay, good. Well, lots of you haven't. Okay, so a lot of instructors don't emphasize that. But anyway, I'm getting into programming principles here, which is kind of fine because programming languages are meant to enforce certain principles or allow you certain principles. So let's go and do this code a little better. Okay, so procedural modularity and uniformity, I never answered this question through the slide before. So uniformity meaning that, every piece of code must belong to a function. Okay, it just makes it more uniform for the human being. It makes it more uniform for the compiler writer and the runtime. So it just makes more sense. Okay, so improved code constructs. Okay, now we are getting somewhere. Okay, we are using C as it should be used, not necessarily as it is used. So I've got now a path. I don't know if you like my names or not. Okay, and that's part of the reason people don't use name constant. They say, who's going to give it a name? Okay, but it's actually better than 60. Okay, so pass cut off, and then I'm going to define one function to do regular pass. Okay, who knows? I'm not going to combine regular pass and my fudgy pass because I might decide later to forget about this fudgy pass and just use regular pass, or use regular pass with some other fudgy criteria. Okay, so I've got two constants for the high final pass, and then I've got my pass function that goes and says, oh, it is either a regular pass or a high final pass. Okay, and if I go and define a high midterm pass later, I use my regular pass, and I define a high midterm pass, and then so I can reuse the code for regular pass because I've separated it from high final pass. Yeah.
Can I ask a question? So for such a very simple, very basic functionality, do we really need these formalities to make things really better?
And you're saying you don't?
I don't know. I'm not a software engineer.
So I just give you a reason. Suppose somebody want to counter him, and he's clearly saying, I don't want to go and do the extra typing. Okay? And give me a reason, concrete reason in this example, not some esoteric principle in software engineering. In this example, tell me why this code is better in some situation. I'm seeing the same people raise their hands again. Yeah. Are you raising your hand?
Yeah.
Okay.
It's more flexible if you choose to change a passing mechanism.
So that, like I said, I want to use the same regular pass, but define a different pass function. Okay? And I want to go and have a high midterm pass function I'll add, and I'll go and make a new pass that is high midterm pass or regular pass. So I've reused the code. Now, how much code did you have to, am I saving you from typing by my method? Not much, right? Just 3 lines of code. So your counter argument might be, I don't mind repeating that code. I'm a good typist. I feel more productive by entering more characters. So, I don't mind doing that. What's the counter argument to that? Yes, it is, and copy paste. Just take your regular pass code and embed that in your new pass function. What's the problem with copy paste? Yeah. Yeah.
So in the future, this happens to me a lot. In the future, if you go back to your old code and you need to change something in whatever you copy and paste it, you have to change it in every single instance of where you copy and paste it.
This is a person who's programmed enough to know the problems. Okay? The problem is never pasting. We are all very good at pasting. The problem is when you change one instance of the code, it will change all instances of the code. Okay? That is the real problem, and I can't tell you How many times I have been bitten by that, even though I preach all this stuff. I'm just like you. I'm too lazy to go and type. I'm a much worse typist than you are. Anybody is, you know. But this is what you get when you don't do it. And also, you know, you can go and give this code and say, I will not comment this code. You give the other code to an instructor and you don't comment it, you lose points for it. Okay, because they'll say, because there's always a danger that somebody doesn't understand what that step is. Okay, so I have made it clearer. I've typed more. Okay, and the main thing is this duplication, that you forget to go and change all copies of that code. That is what happens a lot. Okay. Convinced?
Yeah, thank you. So basically, it's for like future modification.
Absolutely. If you're doing one-time only script, you don't even have a main method. Okay, just get the job done. I want to delete all my files in this directory and I'll never do that again. Just don't even put it in a script. Just enter the command interactively. So this is why people say, when is something good for, you know, later? When is something good for, what context, in what context you use a language? Now we see that context. Okay? But just get into the habit. You never know. I mean, to say that my code will never be changed again is having a very low opinion of what you're writing. Okay? That this is not important enough to be changed and improved better. You know, if you say anything I do is great, it's for eternity, except it'll require some evolution, you'll take this approach. Okay? So again, I say that as somebody who built some tools, and then I said, oh God, I can use this tool even next year. And then I said, why did I not follow the principles I preached? Okay? And Java, I'll tell you, Java design is full of such examples. Well, the reason we have 1.1, 1.2, 1.3, and 1.4 is because they didn't follow the principles that were invented in 70s, in the 90s, because they said, we're too lazy to do it right now. Okay. Okay. And by the way, I've talked to industry people. One of the biggest problems is very long methods, like 300, 400, 500 lines of code, according to one of my students who worked even with Google at Chapel Hill. He said that was a very big. Okay, now, you know, I don't need the comment for that. I've got this method called enable output flush, okay, which hopefully is descriptive enough. So I didn't have to put a comment. And here I'm doing all the I/O. Okay, the input, the output, the logic was in the previous slide. Now I've got the input and output. Okay, and just as you guys suggested, I have an input double method, and which takes a parameter and returns the value, and I call that twice in my main. Okay, no surprises here. Okay, but what is this? For those of you who haven't done operating systems, any idea what is going on here? Yeah. So I'm passing, so it's the address of character. But what am I passing to it? I'm passing a character, or am I passing a, yeah. It's a pointer to the character, exactly. It's an address, very good. Now you're into all the addresses now. But when you look at its use, I say input double, and I'm passing input double a character or a, what am I passing input prompt? Yeah.
Are you passing it a string of characters?
I'm passing a string of characters. So what does it mean to say, why do we say char star? Sorry? String is an array of characters. So it could be an array of characters, could be pointed to a character, and this is pointing to which character in the string? The first one. Okay. So in C, you know, we don't quite know how to type this value. It could have multiple types. Okay, which gives you a lot of flexibility. Okay, but that's being made evident here. But that's also confusing. Okay. Questions? Have you guys seen this in 411? No? You have? Are you sure? We have a big debate in our department as to how much C is being taught. And we are trying to revamp the whole curriculum. So the reason I'm asking all these questions is not to test you, but to test our curriculum. Okay? But at least it hasn't sunk in as much as which is we'll talk about when C is useful. So it addresses first character of a string. Okay, we already saw that this point later. So, by the way, this is bad for understanding, bad for many things. It's really bad for security. Okay, and again, you guys want to know when to use a language. So I spent a sabbatical in Microsoft for a year. I was with the operating system group, and that's when they decided that they will not have any C anywhere in the organization because the code was just being hacked too much. But you really can't do an operating system without some of these functionality. So the operating system guys revolted, and they got to use C, and nobody else could use C. Okay, just because not only does it lead to buggy code, but it leads to insecure code because you can go and access any part of memory. So malicious code could go and come into your computer and access any part of your memory and do funny things that you're not supposed to do, like change your data with some code and execute it. Okay, so this is bad for security, great for OS. Okay, and that's why the OS people are the ones who are most unhappy about not having enough C be taught here. Okay, which is very understandable. Okay, questions? And this is, I think, a Windows quirk that you need to do enable output flush. And this is, again, something that is important. Java was designed to be portable. It's not quite portable, but it's almost portable. So it doesn't let you muck around with addresses because who knows what you're going to get in different computers. C is meant to be OS specific. Okay? So that is why that's why you live with all these quirks, and then you can do many more things because you can make assumptions about the OS, which you can't, which is hidden to you in Java. You have a question? Okay. I kind of see your hand up, so sometimes people are hesitating, so okay. Should I repeat the slide?